Algebra Review Part 5. This review section involves a variety of graphing problems. There's really just a hodgepodge of different things in this little section. And first we're going to talk about the graph of a parabola, which is the graph of a quadratic equation. And the basic graph is this graph at the top, which is of y equals x squared. That's the parent graph for parabolas. It's anchored at 0, 0. And you can see the shape of the parabola there. Now, if you take the x squared and add a number to the back of that, it moves the parabola up. So since it's plus 3, the parabola moves up 3 spaces. If you do subtraction at the end, after the x squared, it moves the parabola down. So x squared minus 2 moves the parabola down 2 spaces on the graph. Where the parabola crosses the x-axis is the x-intercept, and where it crosses the y-axis is the y-intercept. And you can find those by looking on the graph, but you can also find them algebraically. And this works for all graphs, not just parabolas. Y equals x squared minus 2, and algebraically find the x and y-intercepts. To find the x-intercept, you replace the y with a 0. So 0 equals x squared minus 2. And I need to solve for x, so we add 2 to both sides. Then to get rid of the squared, you square root both sides. Remember, when you square root both sides of an equation, you have to put plus or minus in front of the square root. So positive square root of 2 and negative square root of 2 are the 2 places it crosses the x-axis. For the y-intercept, you replace the x with a 0. Y equals 0 squared minus 2. Y equals negative 2. So we saw that when you go down 2, that's where it crosses the y-axis. When you're dealing with 2 points on the graph, there are different types of things we do, trying to find out the relationship between the 2 points. And the first one is the distance formula. I'm not going to do examples of these. You've been using these formulas for years, but just a reminder of what the formulas are. And when you have 2 points, remember they're labeled x1, y1, and x2, y2. The first x and the first y, the second x and the second y. So when you're given the 2 points and asked to find the distance, you'll plug the numbers into the distance formula. The midpoint formula is to add the x's, divide by 2, add the y's, divide by 2. And then the slope formula, m equals y2 minus y1 over x2 minus x1. When we're dealing with circles, the basic formula for a circle is x minus h all squared plus y minus k all squared equals r squared. The center of the circle is hk. In the formula, it's minus h and minus k, but when you pull out the center, it's positive. What that means is that you are changing the signs. So when you pull out the h and the k for the center, you change their signs. And then the radius is just r, not r squared. So the radius is the square root of the number at the end of the formula. So for example, if we want to name the center and radius and then graph, x plus 3 quantity squared plus y minus 2 quantity squared equals 16. The center is negative 3, positive 2. You change the signs, and then you take the square root of 16 to get the radius, which is 4. To graph that, we first plot the center at negative 3, 2. And then we use the radius and count from the center, straight up 4, straight down 4, to the right 4, and to the left 4. Put dots there and connect them to make your circle. It's hard to do a nice circle if you're not using a compass and graph paper and all of that. Just so your dots are in the right place, it's okay if your circle looks bad. Writing the equations of lines is an important skill that you need all the way through calculus and beyond, and this is probably something you've been working on even since pre-algebra. But it's always good to review this, and there's more than one correct way to do some of these things. I always use this little flow chart And I start with 2 points at the very top, x1, y1, x2, y2. And from there you calculate the slope with the slope formula. Sometimes you're given the slope and then you don't have to do that part. Then I always go to point slope form. And I wrote the y and the x a little bit darker because you write an actual y there and you write an actual x in the parentheses. Then the y1, m, and x1 you'll fill in with numbers from the points. After point slope, it depends on what's being asked for. If you are asked to write the equation in standard form, then you get the x and the y terms on the left, everything else on the right. Now some books put all the terms on the left and have it equal 0. But I think the most common form is this one, ax plus by equals c. Standard form has 2 picky rules. The first one is there can be no fractions or decimals in standard form. And the second picky rule is that the a value, the number in front of the x, must be positive. Or you might be asked to write the equation in slope-intercept form. That's with the y by itself. When it's in slope-intercept form, it's easy to graph. The number in front of the x is the slope. And with the slope, the top number tells you how many to count up and down. The bottom number tells you how many to count left and right. The b is the y-intercept. It's where it crosses the y-axis. So let's practice a little bit using these formulas to write the equations of lines. Now I did want to say sometimes another method to find slope-intercept form is skipping point slope form altogether, plugging in numbers and figuring out what b is, plugging in the slope and a point, figure out what b is, and then rewrite the formula in slope-intercept form. If you learn to do it that way, it's fine if you want to keep doing it that way. So we want to write an equation in standard form of the line that passes through negative 5, 3 and 4, 7. I think it's a good idea before you start to label your points. This is x1, y1, and then x2, y2 to help you keep track. If you look at the flow chart on the previous page, wow, that just looks like gobbledygook where I wrote x1, y1. If you look at the formulas on the previous page, it starts with the slope formula. So that's m equals y2, which is 7, minus y1, which is 3, over x2, which is 4, minus x1, which is negative 5. So minus a minus would be plus 5. 4 over 9. So that's my slope. Then the next formula is point slope, which goes y minus y1 equals m, which we just found, times x minus x1. After that, I want to get the x and y on the left, everything else on the right, so I need to simplify some things here. Distribute the 4/9. Y minus 3 equals 4/9 x plus, and remember when you multiply fractions, you multiply tops and multiply bottoms. Standard form is you're not allowed to have any fractions, so this would be a good place to get rid of them. I can get rid of the fractions by multiplying everything by the common denominator, which is 9. So multiplying by 9 all the way across, that will give me 9y minus 27, here the 9's cancel, equals 4x plus 20. I want to move my x over to the left side, so it will become negative, and move my 27 over to the right side, and that would turn positive. So now we have minus 4x plus 9y equals 47. Then the other picky rule about standard form is the number in front of the x has to be positive. If it's negative, you just divide everything by negative 1, which changes all the signs. Positive 4x minus 9y equals negative 47. Now it's in standard form. parallel lines have the same slope, and perpendicular lines have negative reciprocal slopes. That means you flip it over and change the sign. In your textbook on page 112, example 7 gives you a good worked out example involving parallel lines, and then I'm going to do an example involving perpendicular. So it says write an equation of the line in slope-intercept form perpendicular to 2x plus 4y equals 5 that passes through 3, negative 2. So perpendicular lines have negative reciprocal slopes. I need to know about the slopes. If I look at the line that they gave me, I can figure out its slope if I get the y by itself, because when the y is by itself, the slope is the number in front of the x. I'll move the 2x over, so subtract 2x, and then divide everything by 4. And that gives me y equals, and I reduce the fraction, negative 1/2 x plus 5/4. So all I need from that is the slope. I'm going to write a whole new line perpendicular to this line. So my old slope that I just figured out is negative 1/2. If I'm going to do a new line that's perpendicular, the slope will be flipped and the sign changed. So I flip it over and change the sign, my new slope will be positive 2. So there's my slope, and I also have a point that was given to me, and that's going to be my x1, y1. I can do point slope form now, so y minus y1 equals m times x minus x1. It's asking for slope-intercept form, that's the y by itself, so I need to distribute y plus 2 equals 2x minus 6, and then finally get the y by itself, y equals 2x minus 8. So this line and my original line would be perpendicular to each other if we were to graph them. This little review section is pretty much unrelated to graphing, but it has to do with variation, or sometimes it's called proportions. And we have direct variation. Direct variation is when one item goes up, the other item goes up as well. If x goes up, y goes up. For example, if I eat a lot of food, then my weight goes up. If I don't eat a lot of food, my weight goes down. So one goes up or down, the other does the same thing. And that's direct variation or directly proportional. Inverse variation is the opposite. If one thing goes up, the other thing goes down. And that is y equals k over x. Joint variation is like direct variation. It just has more than one letter beside the k. And then sometimes you have a mixture of direct or joint and inverse all together. The k value is called the constant of proportionality. No matter what you put in for x and y, the k is established to always be the same thing, depending upon the situation. And these formulas are used a lot in economics, in physics, sciences, things like that. So we're going to look at a problem that has to do with formula, Newton's law. The force F is jointly proportional to two masses, m1 and m2, and inversely proportional to the square of the radius. Part A says write an equation that expresses this proportionality. So the way you would write that is the force is jointly proportional. So you have a k always, and then if it's jointly, then the variables are beside the k, m1, m2, inversely to the square of the radius. If it's inversely proportional, it's underneath the k. Square of the radius is r squared. This is the force of gravity between two masses. So like the Earth and the Moon, or your body and the ground. And then that's all they want for part A. Part B, find the constant of proportionality if you have values for all of the other variables. So we just fill in 1,000 for the F. We're trying to find K. M1 is 200. M2 is 150, all over the radius squared. 1,000 equals, so if you multiply 200 times 150 and divide it by 25, it's 1,200 K, and then divide both sides by 1,200, and you can reduce that fraction, and it's 5/6 equals K, and then that's all they wanted for that.